Hey, we're back. This is Philozovee.com, and I'm here with Jesse. Jesse's a Kiwi who's been in Tokyo for 2 years.
Mm-hmm.
2 years. He teaches science at an international school in Yotsuya. And I invited him here today to discuss things related to science education and perhaps other topics. We'll see what happens as we progress here. So Jesse, can you give us a little of your background first, perhaps?
My background is in science, particularly physics and astrophysics. I've been teaching about 10 years, some in New Zealand, some in Taiwan, and then more recently in Japan for the last 2 years.
Okay. And what are your thoughts on science education, its importance, and perhaps a better direction it could take?
Well, I suppose I see it as important. That's one reason I do it. I think, if I can say so, generally as a profession, science teachers do a reasonable job, but I do see certain things do frustrate me in life and society, which at times I think, well, obviously, there are times I think there are ways we could do better.
Okay.
Yeah.
Can you elaborate on that?
For example, a large proportion of educated people don't believe that climate change is real or don't believe that it's human-induced, and I see that, given the overwhelming evidence for it, I see that as a lack of understanding of a vast, well, not a vast majority, but a significant number of people who've been through science education. I have to wonder what's gone wrong there.
Right. I have a question I might throw at you. I don't know if you can answer, but how do you feel social media has affected science education?
Do you mean in the classroom or
No.
in society?
Just in society in general. When people believe in pseudoscience, there is the social networks they can utilize to spread those falsehoods. But at the same time, it's also available to real scientists. And
I think I'm going to say it's a two-edged sword, actually. On the one hand, social media has done wonders, I think, for generating interest in science. I mean, I responded, I hope it's all right to say it on this program, but the Facebook, I fucking love science, just shows some brilliant things, and my students talk about it. Oh, I saw this, or see this here or there, and in fact the name generates a few laughs sometimes that's where all this good information is coming from. But at the same time, certainly it does, as you say, allow pseudoscience to spread and perpetuate, and it gives, I suppose, it gives it more time than often it should deserve. In fact, a case rather pertinent here in Japan, and I wasn't here at the time, but I certainly followed it, was Fukushima. I think people really just needed to know what was going on in those reactors, but they also needed the facts, what was going on, and also what wasn't known. I mean, in that first week, I really believe the engineers and the physicists actually didn't really know what was going on, and I sort of had some sympathy for them, and the social media and the internet generally was awash with sort of, what's the word, end of the world, apocalyptical, in Japan there was going to be no more Japan any sort of time. So I'll say a two-edged sword, but I think if people were better educated in science, they'd be able to use the social media in a good way and judge what's good science and what isn't.
All right. And what about critical thinking in the classrooms? Do you think science needs more critical thinking, or how might that be implemented if you do?
I definitely think we need more critical thinking. It can largely be done under the classic experiment, although there's a fine balance between what we call a cookbook experiment in science education, which is the classic chemistry, put 5 grams of marble chips into 10 mils of acid and observe what happens and draw a graph of it sort of thing, which perhaps doesn't foster as much critical thinking. And then there's an open-ended, go and devise an experiment to measure the effective surface area on a reaction rate. I keep using chemistry examples. Somewhere in there lies critical thinking, but I do think there should be a greater emphasis in science education on science as a discipline, how important critical thinking is, and the realities of what drives science and its limitations in terms of, say, our current knowledge. What does it mean if something's a theory? Why do we consider one theory better than another? I think there isn't nearly enough of that in conventional science classrooms.
And what do you think about philosophy in general? Critical thinking is more on the practical side, but what about deeper philosophy? Is that important to younger students?
I think it should be, and I personally think there should be much more of it taught at school. My old school, I actually taught a philosophy course open to high school students, and basically it was, I suppose, perhaps a slightly cut-down version of a first-year university philosophy course, but not really. I suppose perhaps slightly more contextually relevant for high school students, but basically philosophy. And the International Baccalaureate program has essentially a philosophy course called Theory of Knowledge, which I think is a great idea. Unfortunately, I haven't taught it yet.
All right. Since you mentioned philosophy of knowledge, what do you think about knowledge, the concept of knowledge? We've discussed this earlier, so
we have. I actually think, yes, partly following up from our conversation earlier, I think there should be more emphasis on it. So, for example, an example I gave earlier too was that when I tell my students, say during chemistry or a physics class, that no one has ever seen an electron, it's simply a theory. It's a very elegant theory. It explains chemistry and physics with remarkable precision, but nonetheless we've never seen one, and it's possible that a new theory will come out where we say, well, actually there are no electrons. There's a new way to explain the same phenomena that astounds students. You know, they've been taught this since elementary school. And so the idea of to say, well, rather than we know that atoms look like this, to say this is why we believe an electron exists because of, so I think there could be more emphasis on it in schools, definitely.
I see.